हेलो एवरीवन, ज्ञान विजार्ड में आप सभी लोगों का वेलकम है। मैं हूं अजमल। आज के इस वीडियो में अल्टरनेटिंग करंट पासिंग थ्रू ए रजिस्टर के बारे में लर्न करेंगे और देखेंगे कि करंट और वोल्टेज के बीच में कोई फेज डिफरेंस है कि नहीं है। अल्टरनेटिंग करंट या वोल्टेज एक पीरियडिक टाइम पर वेरी करता है, मीन्स वोल्टेज अक्रॉस द टर्मिनल चेंजेज इस डायरेक्शन पीरियडिकली। यहाँ पर एक सोर्स ऑफ ईएमएफ जो अल्टरनेटिंग नेचर का है उसको एक रजिस्टर के अक्रॉस कनेक्ट किया गया है और करंट आई इस रजिस्टर के थ्रू पास हो रही है। हमें मालूम है कि अल्टरनेटिंग वोल्टेज की इंस्टेंटेनियस वैल्यू E इज इक्वल टू दी E नॉट साइन ओमेगा t, where E is the instantaneous value and E naught is the peak value or maximum value and omega is its angular frequency. When I current pass through this resistor, then the total potential drop across the resistor is equal to IR. We can say that the instantaneous value E is equal to the potential drop across the resistor, that is I into R. Therefore, we can write it as IR is equal to E naught sine omega t. Therefore, I is equal to E naught divided upon the R sine omega t. From Ohm's law, we know that I is equal to V upon R. We write it as instantaneous value of the current I is equal to I naught sine of omega t. Where I naught is equal to E naught divided upon R, and this is the peak or maximum value of the alternating current. For DC current, we know that I is equal to V divided upon R. If we compare these two equations, then we conclude that the effect of the resistors in AC and DC current is same, and in both cases it reduces the value of the current. Let's compare these two equations, this and this. E is equal to E naught sine omega t and I is equal to I naught sine omega t. That means the phase difference between the two is 0. That means both EMF and current are in phase. But the value of I naught is here reduced to the E naught upon R. The value of the I naught is reduced by a factor of 1 upon R. Let's see how the phase difference changes for the EMF and current. Both start from 0, reaches the maximum value at the same pi by 2, and both attain the 0 value at pi. At pi, it reverses the direction, and at 3 pi by 2, both have the maximum value in opposite direction, and at 2 pi again it's 0. That means the value of instantaneous current and EMF both attains the 0 and maximum value at the same time. Thus, we can say that when the AC EMF AC voltage is passed through a resistor, current and voltage both are in phase. That means it changes its value between 0 and maximum at the same time. Let's see the phasor diagram of current and EMF. Since phase difference is 0, therefore the phasor of this E0 and this I and the E both have a value of omega t with the x-axis. Here the value of I0, the value of I is less than the value of the E, or we can say here the phasor diagram or the value of the E0 is more than the I0, because from this equation I0 is less than the E0, but both are in phase. If we take the projection on the y-axis, then we get its instantaneous values, that is the E0 sin omega t, and for current it is the I0 sin omega t. Thus we conclude that when AC EMF is passed through a resistor, then current and voltage both are in phase. Hope you find this video useful and informative. Please like it, share with your friends, and write your comments in the comment box. Thank you very much for watching this video.